Here we have a geometry problem. There is a figure given here. In the given figure, we have to find the length of this red color line segment, that is BD. Okay, so my first step, what I'm going to do is I'm going to draw a perpendicular line from the point C to the base AB. So, and also I assume the perpendicular I have drawn in blue color from the point C to the line segment AB intersects a line segment, let's say at the point E. Okay, since this line segment, the line segment which I've drawn in blue color is perpendicular to BC, here we have a right angle. Okay, now let's consider the right triangle BEC. Okay, in this right triangle BEC, what is the length of the side BE? Okay, here already we know the length of the side CD, which is 4 centimeter. Then the length of this line segment is also 4 centimeter, because the blue color line segment is perpendicular and this length is parallel to CD. So the length of this segment is 4, and the total length of AB is 9. If this part is 4 centimeter, then what is the length of this EB? This is 5 centimeters. So that when I add 5 centimeter and 4 centimeter, I'm getting the total length AB 9 centimeter. Okay, in right triangle BEC, I know the length of the leg BE and also the hypotenuse BC, because BC is the side which is opposite to the right angle over here. So I know the length of the hypotenuse BC. So if I use Pythagorean theorem, I can get the length of CE, the perpendicular, which is drawn from the point C to side AB. Okay, now let me consider the right triangle BEC. Okay, now I square the two legs, that is CE square positive EB square. So I square the leg CE and I square the leg EB. It must be equal to the square of the hypotenuse, that is BC square. So according to Pythagorean theorem, I do not know the length of CE, so I can keep CE as it is, that is CE square. And for EB, I know the length of 5 centimeter. I can plug in for 5 for EB, then I'm getting 5 square. And for BC, I know the length 13. So when I plug in 13 for BC, I'm getting 13 square. So CE square positive, the evaluation of this 5 square is 25, and the evaluation of this 13 square is 169. So my aim is to get the length of CE. Okay, for that I have to subtract 25 from both sides. When I subtract 25 from both sides, this positive 25, negative 25 will cancel out. I'm getting CE square equals to, when I subtract 25 from 169, I'm getting 144. Okay, now to get the length of CE, I have to get rid of this square. For that, I have to take square root on both sides. When I do so, this square root and square root will cancel out. When I take square root for a number, usually we will consider positive or negative sign in front of square root. But here, CE represents the length of a line segment. So the length of a line segment can now be a negative value. So in this positive or negative sign, we can consider only the positive sign. So now we have CE on the left side, and square root of 144 is 12. So now I got the length of CE. Okay, but our aim is to get the length of BD. So what can we do with the length of the CE we found so far? That is 12. So if the length of this CE is 12, then what is the length of this AD? So AD is parallel to CE, because both AD and CE are perpendicular to AB. So since they are parallel, they must be equal. So whatever length we have for CE, the same length we'll have for AD. So just now we got the length of CE, that is 12. Then the length of AD is also 12. Okay, now let's consider the right triangle ABD. In this right triangle, I know the length of the two legs AD and AB. So I can use Pythagorean theorem and find the length of the hypotenuse BD, because BD is the side which is opposite to the right angle. Okay, now I'm going to consider the right triangle ABD. In this right triangle, I'm going to square the two legs AD and AB. So that is AD square and AB square. I square the lengths of the two legs and I added them. So now when I add the squares of the two legs of the right triangle ABD, it must be equal to the square of the hypotenuse, that is BD square. According to Pythagorean theorem, we have written this statement over here. So for AD, I know the length is 12, so I can plug in 12 for this AD, then I'm getting 12 square. For AB, I know the length, it's 9, so I can plug in 9 for this AB square. And for BD, I do not know, so I keep the BD square as it is. So the value of 12 square is 144, and the value of 9 square is 81 equals to BD square. So when I add them, I'm getting 225 equals to BD square. So our aim is to get the length of BD, so I have to get rid of the square. For that, I have to take square root on both sides. When I take square root on both sides, So actually here we take a square root for a number. So already I've explained. So usually we take a positive or negative sign, but BD represents the length of the hypotenuse of a triangle, right triangle. So the length of a side can never be a negative value. So we can consider only the positive sign for this one. So square root of 225 is just 15. And so here the square root and square root cancel out, and we just get BD on the right side. So now I got the length of BD. The length of BD is 15 centimeter.